Hello and welcome to another edition of Brain Maths. On today's edition, we want to look at equality of matrices. Two matrices are said to be equal if their corresponding elements are the same. That is, the element in matrix A is equal to the elements in the matrix on the other side. If you look at what we have on the board, for these two elements, for these two matrices to be the same as this one matrix, the first thing we have to do here is to multiply the matrix out. And if you don't forget, in our previous lesson, when we treated the multiplication of matrices, I told you that for any expansion or any multiplication of matrix, what you are expected to do is to multiply a row by a column on the other side. So don't forget that, as we will be using that in this class. Also, equality of matrices means that if we have matrix A to have elements A11, A12, A21, and A22, for this matrix to be equal to another matrix B, the elements in matrix B must be the same as the elements in matrix A, and they are corresponding as it may be. If you look at the first element here and the first element in the other one, which is A, the two of them must be the same. Now, what we are saying in respect to what we have on the board is that they have given us these two. By the time we multiply out and get the values of A and B, what we will be having, the new matrix that we will get must be the same. We must have these four elements as what we're having on the other side of the board. So let's start with question number one. Question number one says 3, 2 minus 1, 4. Also, A, 5, 4, B. They are both equal to 2, 21, 18, and 7. So, the first thing we are going to do here is to multiply these two matrices together. So, we'll be using this first row to multiply this first column and then the second column. So, let's do that. 3 times A will give us 3A plus 2 times 8, 2 times 4 rather, that is 8. Also, we use the same numbers to multiply the second one. 3 times 5, 15, and 2 times B plus 2B. Then you come down, take the second row to multiply the first column and the second column. We have minus 1 times A, that is minus A, plus 4 times 4, that is 16. Also, minus 1 times 5, that is minus 5, plus 4 times B, that is 4B, which is equal to 2, 21, 18, and 7. Now, the next thing we are going to do is to determine the values of A and B. Now, from what we have on the board, to get the value of A and B shouldn't be a serious problem, as we have their corresponding elements in the other side. So all we have to do is to take each one of these and map them with their corresponding element. So for the first one, we have 3A plus 8. 3A plus 8 is equal to what? Is equal to 2. So what is left for us is to solve this. And when you solve this, you are going to have, okay, we have 3A. Take this to the other side. We have 2 minus 8. Then it becomes 3A equals minus 6. If you divide both sides by 3, which is the coefficient of A, A will be equals to -2. Also, we have gotten the value of A. Now look at the second one. This 15 plus 2B is corresponding to 21 on the other side. So take the two of them and equate them to get the value of B. Well, we have 15 plus 2B equals 21. So collect like times and solve to get the value of B. So we have 2B equals 21. If this moves to the other side, it becomes -15. So we have 2B, 21 minus 15, that is going to give us 6. Divide both sides by 2, which is the coefficient of B, and our B equals to 3. So this is to tell us that the value of A in this whole equation is -2, while the value of B is 3. Now we need to test to confirm that what we have gotten is actually correct. As we said from the beginning that we are equating, we are finding the equality of matrices. When you substitute -2 into this, you must get 2. And when you substitute 3 into this or this, you must also get whatever their correspondence value is. So let's start with A. If A is -2, 3 times -2, check. 3A plus 8 becomes 3 times -2 plus 8. And 3 times -2 is what? -6 plus 8. -6 plus 8 is what? 2, which is actually what we have on that side. Let's take another one. Let's test for this second part of the B. We have -5 plus 4B equals, wherever we see B, we change to 3. -5 plus 4 times 3, which is -5 plus 12. And -5 plus 12 is going to give us 7. So we don't need to stress ourselves much on this, as we have seen that this matrix is the same thing as this matrix after we have gotten the value of our A and B. Having solved question number 1, let's try to look at what question number 2 is going to give us. Question number 2 says matrix 3, 4, -2, 5, and A, B equals -3 and 25. Now let's quickly do our multiplication and then map out correctly. So we take row 1 and the only column that is given to us, that is going to give us 3A plus 4B, and that is equals to what? -3. Then the second one, mapping again, we have -2A plus 5B. So this is its own matrix, and this is the second matrix, which is 25. So this one is equal to this. If you're looking at this closely, you will see that it has given us something that is very close to a simultaneous equation. So we can remove the bracket and solve it simultaneously. So we are going to say 3A plus 4B equals -3, 2A minus 2A plus 5B equals 25. So we need to eliminate or substitute as the case may be. For this case, let's try to eliminate A. So to eliminate A, we multiply equation 1 by the coefficients of A in equation 2 and equation 2 by the coefficients of A in equation 1. And that is going to give us 2 times 3A, 6A, plus 2 times 4B, 8B, equals 2 times -3, -6, 3 times -2A, -6A, and also 3 times -5B, that is plus 15B, equals 3 times 25, 75. Now we have to eliminate A. if you look at this place, we are already having a negative. So which sign are we going to put here to give us a sign that will still give us a 0? So it is better for us to use a positive. Plus times minus will still remain minus. 6 minus 6 will give us 0. So that is eliminated. 8 plus 15 will give us 23b, which is equals to minus 6 plus 75. That is going to give us 69. So we divide both sides by the coefficients of b, which is 23. So our b now equals to how many? 23 in 69? That is going to be 3. Having gotten the value of b to be 3, then we come to equation 1 or 2 to substitute this value in order to get our a. So we say from 1, 3a plus 4b equals minus 3. So we have 3a plus 4 times 3 for the value of b equals minus 3. 3a plus 12 equals minus 3. And when you collect like times, we have 3a equals 12 minus plus 12 minus 3 minus 12. That is going to be minus 15. And the value of a will be equals to 5. When you substitute and when you cut that, how many 3 can we get in 15? Our a equals to minus 5. And the value of our b equals to 3. Now let's check to confirm that the answer we have gotten is actually the same as what we have on the other side. Now let's try to substitute the value of a in the first one here. A is minus 5. 3 times minus 5. Check. 3a plus 4b. Is it actually equals to minus 3? So 3 times minus 5 plus 4 times 3. 3 times minus 5 is minus 15 plus 4 times 3 is 12, and that is equals to minus 3. Then if you check for the second one, you must also get 25. Let's check that as well. Check 2. You check 1. Let's check 2. Minus 2a plus 5b. Our a is minus 5 minus 2 times minus 5 plus 5 times b, which is 3. Minus 2 times minus 5 will give us 10. Minus times minus cancel out. Plus 5 times 3, 15. And 10 plus 15 is actually equals 5. So the check 1 is correct and the check 2 is also correct. I'm going to be leaving you with this question on the board. We are having two 2 by 2 matrices mapped together that is equal to another matrix on the other side of the board. You are expected to find the value of x and y, and after getting the values of x and y, also try to check to confirm that the answer you have on each side of the matrix is actually the same as the corresponding answer on the other side of the matrix. We are going to be rounding up on this edition here, and before I come to you next time, don't forget to subscribe to this channel if you have not done so as usual, and also help us to send this video to as many schools, as many platforms where you feel it will be useful as possible. Before then, do have a blessed day.